welcome to my presentation. My name is Yinan Zhang. I'm going to present this research, which is strengthen the RC column with multiple reinforcement. So what is RC column? It's named reinforced concrete column, like this structure. The column supported with the steel rebar and filled in with concrete. So why should we study this? As the population in the Earth is increasing and the space in this planet is limited, so the construction will be set in those places could happen disasters like earthquake or tsunami, even military attack. So to support the construction to confront these multiple hazards, we have to develop a reinforcement to deal with this. So reinforcing the concrete column is a common way to achieve this goal. And in this reinforcing concrete column, the most popular reinforcement is attaching the external material. For example, the carbon fiber reinforced polymer and the glasses fiber. These two materials could increase the column with fatigue loading and ductility. Also, the glasses fiber could increase the column, the resistance of corrosion. And another one is textile reinforced mortar. This material could improve the concrete column as efficient as the fiber reinforced jacket to let the column improve the ability to deal with the seismic loading. The third is configuration. This is commonly used in the shear wall. Like this chart is set with 4 different configurations, and after the seismic loading, the shape with X configuration performs the best. The last one is the tube steel encasing reinforced concrete. This is used the tube steel to encase all the concrete column, and it could improve the column in axial and eccentric loading. The second method to reinforce the column is use spiral and stirrups. Firstly, the twisted opposing rectangular method is this chart. It's used two twisted opposing stirrups to confine the column, and it compared with the conventional one and the single stirrups. The result shows that this one could let the column perform better under seismic loading and seismic loading. However, this method also could consume more energy. Another one is used 2 layers of stirrups. This experiment shows 3 types of column, like this: 2 circles, 1 circle in a square, and 2 squares. He used these 3 columns to show that no matter what the shape the concrete column is, the 2 layers of stirrups could improve the behavior of axial comparison. The last one is the comparison with different spiral. As you can see this chart, the research developed the comparison with different stirrups. The 7 and this 11 is performed better in this test, the cyclic loading test, but also it costs more man hours. As you can see, it's a very complicated structure. The third method is use alternative materials, like the hybrid polytechnical fiber. They used this material to replace the major steel in the column, and it could improve the column in ductility and carrying loading ability. And the shape memory Alice. This is the metal could recover its shape after it change after it be after loading. So this could use in the seismic loading, and the result shows it's very potential. However, but it is only could be used in the long-term earthquake. And the last one is a high strength steel. This is a different steel degree to use in the same geometric structure, and the test result shows that under the high shear stress, the different degree steel could show different ability, like more strength, the steel could carry more loading, it shows less ductility. But on the contrary, the one which could carry less loading, it shows more ductility. So all this previous study, the reinforcement was aimed to deal with one particular disaster, like on the list. But how do we deal with the multiple hazard? I mean, if a place like Japan is always happen earthquake, but if the tsunami happens there, the building and construction will be vulnerable again. So the residents still are threatened by the disaster. So to solve this problem, I designed like this. The first set a segment group. This group have a thin concrete column, and each tool was reinforced by different reinforcement. Like for example, we have 10 reinforcement, and this group will have 22 specimens, including 2 conventional columns. And second is to set the test. The test will cover all the possible disaster and stimulate all the loadings. So the group number should be equal to the amount of the test. The third is to analyze all the data and evaluating them, ranking all the reinforcement by their behavior in each task, then selecting one best reinforcement in each area, one for the external attachment, another for the spiral or stirrups. The third is for the alternative material, and integrated these 3 methods into one column and test all over again. So this could provide an insight of multiple reinforcement column. This design have comprehensive test. I mean, it covered all the stimulation, all the disaster, and the data was reliable because each reinforcement have 2 segments, and the result was obviously compared with the conventional one and each other, so it could provide the disadvantage and advantage of this every reinforcement. The bad of this design is the experiment is too much. It's redundant. It will take maybe it will take years to finish this. So the data will be difficult to analyze, and the evaluation will be a little bit unofficial because the criteria couldn't be provided. For example, there is no sign of that government provides a list that the construction should be considered the earthquake primary or tsunami primary. So we can't judge with our criteria. So overall, this design actually have this potential to achieve, and if we achieve this research, tremendous casualty could be prevented, and all the construction of civilization could be expanded to everywhere in this earth. Thank you for watching. This is the reference.